Hello everybody, in this video I will introduce to you a method to solve signal operations when there is a combination of time shift and time scaling operation in one problem. In this video, let's use this signal xt as a signal that is subjected to signal operations. The question is, find yt, which is given by minus 50 x minus 2t minus 1. In this equation, looks like there are a number of amplitude and time operation involved. The first one is the amplitude scaling with a factor of 50. And an amplitude inverse. A time shift operations. Looks like in this case the t0 value seems to be equal to 1, but is that true? Is that correct? A time inverse, and lastly time scaling operations where the scaling factor could be equal to 2. So let's try a combination of signal operations with a specific sequence of operations like this. From the original signal xt, let's say first we apply an amplitude inverse to get minus xt, and then amplitude scaling to get minus 50 xt. After that, time inverse to get minus 50 x minus t. Then time scaling with a factor of 2. And finally, a time shift. Let me label every operation. Now let's see the final outputs of these operations written in black color. So this sequence of operations with these particular parameter values will produce minus 50 x minus 2t plus 2. And if we compare the outputs with what the question wants, then obviously we know that this sequence which the parameters values will produce the wrong answer. So we need to adjust. Let's say we replace t minus 1 with t plus 1 over 2. So by doing this small adjustment, this sequence of operations will produce minus 50x minus 2t plus, minus 50x minus 2t minus 1, which is exactly the same as what the question wants. So these two are similar. Then we can use this sequence and the parameters values to find yt. Let's call this method try and adjust method, because first we try by guessing the sequence and the parameter values of the scene operations, and then we test the final answer. Is it the same with what the question wants? If not, then we need to do some adjustments. So that's why let's call this try and adjust method. So based on the previous sequence, firstly we need to do amplitude inverse, and then amplitude scaling with a factor of 50, and then time inverse, and then time scaling with a factor of 2, and then lastly step number 5, we do time shift with a factor of minus 1 over 2. Why minus 1 over 2? The generalized time shift operation is like this. If we have a signal ft and this ft is subjected to time shift operation to produce another signal called gt, then mathematically we can write this operation as gt equal to ft minus t naught. So this is standard, and if t naught equal to 1 over 2, then gt equal to ft minus 1 over 2. So oppositely, if t naught is a negative value, for example t naught equal to minus 1 over 2, then gt is equal to ft plus 1 over 2. So clearly in this case, t naught is equal to minus 1 over 2. Now let's see if there is another valid sequence of operations, sequence of signal operations. Firstly, amplitude inverse, which is we start with the amplitude inverse and then amplitude scaling. After amplitude scaling, then apply time inverse to get minus 50x minus t. So the difference starts here. Instead of time scaling, we apply time shift operations to get 50x minus t minus 1, because let's say t naught equal to 1. Then after that, apply time scaling to get minus 50x minus 2t plus 1. Why minus 50x minus 2t plus 1? This is relates to the previous operation. Minus 50x minus t minus 1 is actually minus 50x minus t plus 1. So let me label again. Amplitude inverse, and then amplitude scaling with a factor of 50, and then time inverse, and then time shift with a factor of 1, and then time scale with a factor of 2. by doing this at the end of the operations, without sketching the signals. If we do sketch the signals, then what we actually get is minus 50x minus 2t plus 1, which is different than what the question wants. The question wants us to find yt, which is equal to minus 50x to t minus 1. So there is a little bit of wrong, so we need to do some adjustment, 1 or 2 adjustment. So let's adjust the time shift parameter values. Instead of t0 equal to 1, then we choose t0 equal to minus 1. So by doing this, the time shift will produce minus 50x minus t minus 1. And then we apply the same time scaling operations with a factor of 2 to get minus 50x minus 2t minus 1. So we have found the right sequence with a different sequence compared to the previous one, with of course different parameter values of the signal operation. So we have found two sequence actually based on the what we call try and adjust method. The first sequence is involve amplitude inverse, and then amplitude scaling, time inverse, time scaling, and step number 5, time shift. For the second sequence, the first 3 steps are similar, but step number 4 is time shift, and step number 5 is time scaling. Similarly, for the step number 4, why time shift is a factor of minus 1? This is because t0 is equal to minus 1. So given xt, both sequences with identified parameters value should able to produce yt given by minus 50x minus 2t minus 1. Prove it and do it yourself. That's all. I will see you in the next video.